Hello, my name is Anu. I'm an automation engineer at Zip Automation, Lagos, Nigeria. Today I'll be doing a simple demonstration controlling an electric motor using Modbus. In this case, I'll be using Modbus with an Allen Bradley Compact Logics PLC. Over the years, control has shifted from the traditional 4 to 20 milliamp control methodology to Modbus. So I'll be highlighting the advantages of Modbus over the traditional 4 to 20 milliamp control. Typically, if you want to control a motor using a variable frequency drive, you need an analog output module to vary the motor frequency. You need a digital output module to start and stop the drive. You also need an analog input module to receive frequency feedback and a digital input module to receive on and off statuses of parameters. Now, the big downside to all this, though, is the high cost of wiring and installation, and also limited number of feedback and control parameters. Modbus offers you access to more parameters over a single line of communication called bus. So here is my setup, and for this demonstration, I'm going to be using a Compact Logics L32E PLC. I'll be using a Modbus RTU module. I'll also be using a PowerFlex 40 variable frequency drive that is connected to the motor, and a Panel View Plus 600 HMI. In this demonstration, the PLC is the master and the drive is the slave. So now I'll be connecting my communication cable. One side, I'll be connecting it to the drive. And the other side, I'll be connecting it to my Modbus module. And as you can see, we have communication. So here is the program in RSLogix 5000 that I wrote for this process. So the first set of rungs that you see here, they are for feedback. This is drive ready, drive active, drive forward, drive reverse, drive accelerating, drive decelerating, alarm, and so on. The second set of rungs that you see here, they are for control. Here is drive stop, start, jog, clear fault, forward command, reverse command, and we also have some more statements here that we're going to be using to control the frequency of the drive. So this is my Panel View Plus 600 displaying what I just showed you in my program. So here I have some buttons for jog, start, stop, clear fault, channel enable, forward, reverse. I also have where I can change the frequency of the motor, or I could use the slider, and I have a gauge giving me the feedback frequency. I also have a screen for different statuses. Earlier I mentioned that with Modbus you have access to more parameters. So here are different parameters that we have more access to. We have drive ready, motor running, forward, reverse, accelerating, decelerating, and so many others. So I would be changing the frequency of my motor. I'll be putting in 35 and I'll start, and as you can see on my drive, it has already reflected and it's in the forward direction. So now I would be changing the direction to reverse, and then it decelerates. It's starting to decelerate, and then it begins to accelerate. So here you can see that it's in the reverse direction. So I'll change the frequency now to 50 Hertz, and you can see it's accelerating to 50 Hertz. So I would be deliberately creating a fault so we can see an indication in our HMI. So to do that, I would be changing the mode to program, And then as you can see on our drive, there is a fault created already. So here on our HMI, you can see the fault indicator blinking. So to clear this fault, I'll click on my clear fault button, and then the fault has been cleared. Fieldbus technology offers you a simple and convenient way of controlling drives and other field devices and integrating them into an industrial automation system. Having the basic knowledge of the traditional voltage and current control is good for an automation engineer, but having knowledge of Fieldbus is even better. Thank you for watching.